Lately, there have been confusion among operators deploying SCC within their infrastructure for the first time, which has prompted me to discuss in detail the importance of a two-NIC architecture within Supermicro's SCC platform. In the first two diagrams, we show the viewer the hierarchical framework of our SCC infrastructure for both SCC bare metal and SCC VM Guest instance deployments. The bottom host layer is the one of extreme importance to you, especially deploying in both greenfield and brownfield buildouts. A typical deployment would have you connect each of SCC's NIC interfaces to Tor switches. During platform installation, both physical connections are tested for connectivity. If any one of the connections were not reachable, the script would fail. This poses somewhat of a challenge for complex environments because they already have an infrastructure existing that may or may not support this current configuration. So let's hold that thought for a moment and talk about the happy path, environments where no existing infrastructure exists. Less complex environments may deploy the SCC appliance where one NIC connects to a managed network and the other NIC connects to a Pixie network infrastructure. The first NIC LAN 0 or Bridge 0 usually connects to an enterprise management network and provides outbound traffic to the internet behind some kind of firewall, protecting itself from cyber attacks. The second NIC LAN 1 or Bridge 1 refers to the Kubernetes CNI or SCC's private network. SCC deploys a Pixie microservice container that utilizes this network for OS deployments, maintaining its Pixie network segmentation. Other microservices that exist utilize this network, such as SSDP protocol, device discovery traffic, SCC's heartbeat network, and a microservice responsible for resource pooling. Ideally, customers would segment their internal NIC Bridge 1 network traffic to an isolated switch focused exclusively to forward packets for the purpose of microservices highlighted above. That might be a good option for operators that wish to deploy in a greenfield first-time setup or POC where complexities don't exist for an already predefined infrastructure. What about administrators that already have a Pixie infrastructure already defined? What about those administrators that don't want to define a Pixie infrastructure and already have other methods to deploy operating systems for their servers? What if there are enterprise operators that want to do some kind of network segmentation? Starting in SCC version 3.10 and beyond, we will roll out a phased approach, releasing production builds to solve each of these three challenges that customers face within their infrastructure. Starting with the release version 3.10, we eliminated the need for a second NIC. This change in architecture brings customers flexibility and streamlines their SCC install experience. Eventually, customers will be able to choose a OS microservice they wish to deploy. During the SCC installation process, customers get to choose on their OS deployment requirements or method. Perform a virtual media mount at scale without having to rely on an SCC predefined Pixie network. Choose to deploy a SCC predefined Pixie network infrastructure of their choice. By eliminating the need for a second NIC, customers now have the flexibility to utilize their own metal as a service or bare metal as a service options that best fits their data center operational requirements. So what's different in SCC's VM instance architecture? Although the SCC VM base kit gets deployed on an instantiated VM guest instance, it doesn't rely on a VM layer to forward packets like implemented in SCC's bare metal configuration architecture. What do you mean? You said that both implementations don't require a 2-NIC architecture. That's correct. Both implementations don't need a second NIC cable connected, nor the second NIC bound to the bridge interface. In the SCC bare metal framework, we still preserve the bridge interface, giving administrators the ability to still connect through their management network utilizing its NAT server external management subnet. SCC's NAT server implementation connects to both bridge interfaces, allowing packets to be transferred between itself and the K8 cluster. Notice in the last reference architecture framework for a SCC VM guest deployment, we don't have any bridge interface bound nor a VM layer required to forward packets between the NAT server and the K8 cluster or the K8 pods. It's important to note that our SCC agent, subsystems, and engines rely on the K8 cluster or K8 pod layer for their intercommunication between agents.